Hello, Professor Jackson here. Recently, a student had this problem. How's it going? Prof. Jax right here. Recently, a student asked this question. We are to write as a single logarithm this multi-log expression. And so, first thing that often comes up in these problems, is that you have a radical, and since the laws of logarithms don't really deal with radicals, they deal with exponents, because a logarithm is an exponent, we will write this as an exponent, an argument of the logarithm, that is the input of the logarithm, with an exponent, using this rule right here, that the nth root of something is the 1/nth power of that thing. And of course, here we've got a square root. The index of the radical is 2 of x, and so that's going to be the 1/2 power of x. So we'll write it like that, which will help out a little bit later. Log base 6 of the 1/2 power of x, and from that we're subtracting log base 6 of x cubed. Well, then of course we need to use a property of logarithms. That's what this problem's about. How well do we know these properties of logarithms? Like this one right here, which says that the log of a quotient is the difference of logs. Well, that's what we have, a difference of logs, and so we will be able to write that as a log of a quotient, a single logarithm. So this is log base 6 of a quotient of the two arguments. Log base 6 of first thing, x to the 1/2, over second thing, x cubed. Okay, well, we have a single logarithm, but it's pretty ugly, so we're going to make it look better. And we're going to use this property of exponents, law of exponents, which says that if we're dividing exponential expressions with the same base, we can subtract the exponents. So then we have log base 6, x to the, subtract the exponents, 1/2 minus 3. And of course we're going to want to clean that up. We're going to want to add these or subtract these fractions that are in the exponent. So we can write one fraction for that. Well, that means we have to get a common denominator, which is going to be this 2. So we're going to write this 3, which is 3 over 1, as having a denominator 2 by multiplying it by 1 in the form 2 over 2, making it 6 over 2. So we could take a step to write that just to make sure everything's absolutely clear. Log base 6 of x to the 1/2 minus 6/2, which is log base 6 x to the negative 5/2. 1/2 minus 6/2, negative 5/2. We don't want a negative exponent, and the problem actually also says, I didn't write all the instructions here for this, this is 59 in Sullivan's College Algebra, section 6.5. Not sure of the number in my math lab, but the problem says that we are to write exponents as factors. And so at that point we use the old throw it down rule, which is the big rule for logarithms. Okay, that's the 5/2 power, negative 5/2 power. And we're going to throw that negative 5/2 down front as a cofactor. So take negative 5/2, a law of logarithms, one of the three along with this one, right? Says you can throw down that thing and it's going to be negative 5/2 times the rest of it. Negative 5/2 times log base 6 of x. And that's what they want. That's the answer. Okay, and we've contracted, we've written a single logarithm in the way that they've wanted. That will get it done for that one.